Good morning, everyone. My name is Ainhoa, and I'm speaking to you today as a student of telecommunication engineering. Now I'm going to introduce my team members. Immediately, you are going to meet Arnau, who studies electronic engineering. Next, you will see Paul, who studies telecommunications engineering. Later, you will meet Paula, who also studies telecommunications engineering. And finally, you will see Andrea, who is studying telecommunication engineering too. Thank you very much to hearing us today. I hope that you find this presentation quite interesting. So, okay, let's get started. Have you ever thought about how we can receive messages from the other part of the world as quick as a wink? Then I have to tell you that you can receive emails, WhatsApps, messages, or any kind of communication thanks to fiber optics. It is possible because of a network of cables that are placed underground and under the ocean. The cables that carry most of the world's information are fiber optic cables. Any kind of information could be represented by zeros and ones. I will give you an example. If you want to send a message like hello, this word will be converted to a binary code equivalent to a sequence of zeros and ones. After this conversion, your mobile phone will convert these zeros and ones in the form of electromagnetic waves. The number 1 is transmitted as a high frequency, and the number 0 is transmitted as a low frequency. Your local telephone tower captures these electromagnetic waves, and in the tower, if the message has a high frequency, a pulse of light is generated. These pulses of light can be transmitted through these fiber optic cables. So, as we can see in this photography, the entire world is covered with fiber optic cables. This photo shows us the set of submarine cables in the world. According to the telegeography calculations in 2018, there were 448 submarine cables. It is a figure that is constantly changing because new cables come into operation very often, and others are removed because they have stopped working. So it is estimated that the total of these cables in operation would form more than 1 million kilometers in length. The cables are placed in selected places, so fishing sites or with unsuitable characteristics should be avoided. The deepest point where there is an underwater telecommunication cable is the Japan Trunk. The network is a depth of 8,000 meters. If there is a part of the world that does not have fiber optic cables, this part will be isolated from the internet or mobile phone communications. So what we would like to do this morning is explain you more about this great invention of engineering. So today we would like to talk you about optical fiber. We are really interested in this topic because we are 5 students of engineering and 4 of us are studying telecommunication engineering. We are really into new technologies, and we believe that it is a topic unknown by a lot of people, so we decided to let you know a little more about it. The subject can be looked at under the following headings. To begin with, Arnau will tell you the history of fiber optics. Then Paula will explain you what is optical fiber. Following that, Paul will tell you how it works, and then the applications that it could have, and finally the advantages and disadvantages. And last but not least, Andrea will explain you the different types that can be found, and finally the future that is expected for optical fiber. We plan to be brief. We will only take 20 minutes of your time, and there will be time at the end for questions and comments, so please save them for the end of the talk.
As far as Roman times, glass has been drawn into fibers. Yet it was not until 1870s that French brothers Chapier invented the first telegraph. It was a system comprised of a series of lights mounted in different towers, and operator would relay a message from a tower to another. In the 1840s, Daniel Goldman and Jacques Babinet showed that light could be directed through jets of water. And later, John Tyndall demonstrated that light could travel through a curved stream of water. Thereby, a light signal could be bent. And he wrote a book about it later. Dr. Rothman Royce of Vienna were using bent glass rods to illuminate body cavities during 1880s. And during the 1890s, David Smith from America applied for a patent of a dental illuminator that was a curved glass rod. Heinrich Lamb was the first person to transmit an image through a bundle of optical fibers in 1930. And once again, he was trying to illuminate parts of the body that wasn't accessible at that time for humans. The first working optical data transmission system was demonstrated by Manfred Buhrer at Telefunken Rakuten Labs in 1975. And NASA used fiber optics in the television cameras that were sent to the moon. Later, Charles Cow and George Hockham were the first to introduce that the attenuation, that is a property of optical fibers, could be reduced to a critical point of 20 decibels per kilometer. And that discovery gave them the Nobel Prize in Physics in 2008. This crucial attenuation limit was broken in 1970, and from there the attenuation has been going down drastically, and now the optical fiber cable attenuation is smaller than a regular electric copper cable. Okay, there's a field, an emerging field called photophonic crystal that led to the development in 1991 of photonic crystal fibers, which guides light by diffraction rather than the total internal reflection that we talk about in the book of John Tyndall. These photonic crystal fibers became commercially available in 2000, and they can carry much higher power than conventional fibers. So to sum up, the reflection has always been developing alongside humans, and from the Roman times to now, it has been developing with us. So now Paula is going to talk about what is an optical fiber. Thank you.
Fiber optics is a long and a thin strand of glass about the diameter of a human hair. These strands are arranged in bundles called optical cables. Fiber optics is actually a transmission medium to carry signals over long distances at very high speed. We rely on them to transmit light signals since they transmit most of the world's data. as Ainhoa said before. There is a total length of 1,100,000 kilometers of fiber optics cable. To be able to decide the best route for them, they study their beginning and their end, and they always try to find sand. The cable is made in function of its underground route, and it's determined which jacket they are going to be made of. For example, if the cable goes under the ocean, it is going to need more protection near the beach because of people. So let's talk about how they are made. So I'm going to explain what the simplest optical cable is made of using this picture. So we can see the core. It's the strand of glass about a centimeter of diameter we've been talking about, where the information goes through. Then we have the cladding with a lower refractive index than the core. It has its sense to be able to transmit the light through, and it is going to be explained later. So the core and the cladding are the useful components for the light transmission. Then we have the coating that is really useful and needed to protect the core. And then there is a strength member, the strength member that is made of steel or fiberglass. And finally, we have an outer jacket that is made of polymer layer. So all this set is susceptible to traction and sensitive to impact. That's why optical fiber are covered, grouped, and protected by forming different types of cables. So we can differentiate the cables by 4 different aspects. The first is a single and multimode fiber. The single fiber is a yellow cable. It has a smaller diameter than the multimode fiber, and it only allows a single emission, so it can carry signals in a faster velocity with less intensity. It is perfect for fast transmission velocity or long distances. Multimode fiber is an orange and blue cable. It can carry more than one code of transmission, and it is used for short distances. So the differences between them is where to use them because of the signal they can carry. So if we compare according to the mode of transmission, we have simplex and duplex optical fiber. The simplex is this, we can see here in the picture, has one fiber and one connector in each extreme, while duplex optical fiber has two fibers and 2 connectors in each extreme. Each fiber is marked with an A or a B, or they use a protective covers with different colors to differentiate them. We can divide the types of fiber opticals with PVC cables that are soft and they can be used anywhere, and then we can see LSZH that are more rigid since they don't emit toxic gases when they are burned, and they are pretty much used between flats. And finally, the last group is according to their connectors. There are a lot of connectors, so this variety allows us to connect the fiber cable quickly on an optical switch or any telecommunications device. Every connector can have 4 different endings, so in this picture we can see these endings.
The technology of optical fiber has to do with physics, specifically the concept of reflection. In this case, reflection is used as a method to let light be trapped within a conductor, and this takes advantage of its speed as a means of data transmission. Because this factor is given, the light must influence at a certain angle to cause the so-called angle limit, which will produce a total reflection, leaving the light trapped inside the conductor. In order for the reflection to be carried out, certain requirements have to be met, which have to do with the reflection index of each environment. The reflection rate is what will determine the speed of the transmission of light according to the environment in which is it found. The value of the reflection index varies according to the environment in which is it found, which is why the fiber coat needs a coating that acts as an insulator. One of the different parts that make up the cable, only the core acts as a light conductor. This nucleus is formed by a mixture of doped glass that favors the reflection index. For the light to travel through the core, light should affect an angle of 42 degrees. The light travels in form of pulses. Then we will see what uses of optical fiber are. The fact of transporting light through the cable has constituted a revolution in the information world, and specifically in telecommunications. The fact is that currently the optical fiber is used in almost all sectors due to its fast speed transmission. Light can transmit any kind of information, which is why the demand for optical fiber has increased in most sectors in recent years. Thanks to the speed of data transmission, there are some specific sectors that benefit more than the others, such as the telecommunication sector is the highest beneficiary. Optic fiber has been a breakthrough in data transmission. The world of medicine has also been affected by the arrival of this new technology, improving the usefulness of some devices, such as gastroscopes. Lastly, the world of industry in general is constantly benefiting from the use of optical fiber in the use of satellites. It must be said that the use of optical fiber is infinite, but because of its cost of production, there are very few companies that can afford it. Once explained the operation of the optic fiber and the market in which we move, we will see the reason for this technological revolution. We will analyze the pros and cons that provides us with respect to traditional copper cables used so far. One of the great improvements that fiber provides is its ability to relay data thanks to its volume. As we can see in the first photo, the capacity of a single copper cable equals thousands of optical fiber. In addition, the fact that it does not circulate electricity through it prevents the creation of electrical interference, which causes the loss of information. As we said earlier, light can transmit any kind of information, which electricity does not. This causes in a single fiber cable can transmit different types of information. Despite all these advantages, fiber is subjected to extreme climates, as it might be, for example, under the ocean or under a desert. That is why it has a very high cost, because, as we mentioned before, the index of refraction is not to be affected. In addition, as we all know, the glass is quite fragile, and this causes that the optic fiber cables are quite fragile and require extra protection.
So, in the next 5 years and beyond, contractors expect to use fiber optic cable to improve connectivity in a wide variety of projects. For instance, Forbes magazine reported recently that cities around the globe are beginning to use fiber optic cables for their communication needs. San Francisco, for example, is creating citywide fiber optic networks as a way for trending the internet as a public utility. The Pacific Light Cables Networks, meanwhile, has a turn to run 8,000 miles of fiber optic cables under the sea from Los Angeles to Hong Kong to meet the growing demand for language arising from the poverty of social media and Google. Additionally, the expansion of new 5G wireless technology is being made possible with the help of fiber optic cable. Fiber optic technology itself continued to develop alongside the increased demand for greater speed and efficiency. New devices called optical cables and optical switches support a new communication trend called AON. This technology allows data to transmit without any electrical processing, which in turn can result in the further transmission distances. Another advance that is improved fiber optic technology is called ROF. This system allows for transmission of radio frequencies using optical fibers, which are not impacted by electromagnetic interferences. Part of the reason that industry are rapidly improving fiber optic technology is simple because both business owners and everyday individuals expect greater transmission speed and quality with each passing day. Over the next 5 years, citizens of every country throughout the world will be consuming more social media, streaming video, network, gaming, and other services that rely on fast, clean internet. Temperature sensors used the wearable devices and smartphones also use fiber optic technology. This sector of technology will be in the high demand for healthcare equipment, energy companies, and the automotive industry. Finally, experts believe that fiber optic may prove to be more useful than wireless of increasingly sophisticated electronics. I'm going to present the several terminologies of FTTX that can be categorized according to the different networks destination, such as FTTH, NCB, P, etc. In FTTN, fiber to the node development, the optical fiber terminates in a cabinet which may be as much as a few miles from the customer property, and the final connection from the street cabinet to customer property usually uses copper. FTTN is often an interim step through full FTTH and is typically used to deliver advanced triple-play telecommunication services. In FTTC, fiber to the curb, development optical cablings usually terminates between 3 yards of the customer premises. Fiber cables are installed or utilized along the roadside from the central office to home or office. In FTTB, fiber to the building, development optical cablings terminate at the buildings. Unlike FTTH, which runs the fiber inside the subscribed apartments, until FTTB only resets the apartment building's electrical rooms. The signal is covered to the final distance using non-optical means, including twisted pair, coaxial cables, wireless, or power line communication. FTTH is commonly associated with residential FTTH, fiber to home services, and FTTH is certainly one of the faster growing applications worldwide. In FTTH development, optical cablings terminate at the boundary of the living space so as the rich individual home and business of where family or office can both utilize the network in an easier way.